Today, we will continue with electronic configuration. And if you see the screen, I have given three different examples: magnesium, chlorine, and neon. So let's start off with magnesium. Now we have already discussed that X stands for the element, A stands for the mass number, and Z stands for atomic number. So in magnesium, the atomic number, that is Z, is equal to 12 and mass number A equals to 24. We have also discussed that atomic number is equal to the number of protons, which in turn is equal to the number of electrons. So if atomic number is 12, the number of protons will also be 12 and the number of electrons will also be 12. Now the number of neutrons. I have already discussed that the number of neutrons is equal to the mass number minus the number of protons, and number of protons is equal to the number of is equal to the atomic number. So we can also say number of protons equals to A minus Z, that is atomic number minus the mass number, so which is equal to 24 minus 12, which is also equal to 12. Now we come to the electronic configuration, that means the arrangement of electrons in the orbit. We know that the number of electrons is 12. So the first orbit, as I've told you, contains maximum 2 electrons. So in the first orbit, there will be 2 electrons. Now 12 minus 2 is 10. So we have 10 more electrons left. Now in the second orbit, we can have maximum 8 electrons. So in the second orbit, we will put 8 electrons. So how many left now? 2 plus 8 equals to 10. That means 2 more electrons. So the third orbit will now have 2 remaining electrons. So we know first orbit maximum 2 and after that maximum 8 electrons. So, and I've also told you, without filling the first orbit, I cannot go to the second orbit, and without filling the second orbit, I cannot go to the third orbit. So the electronic configuration of magnesium becomes 2, 8, 2. That means in the first orbit 2, in the second orbit 8, and in the last orbit 2 electrons. Now we will draw the orbit structure diagram according to the electronic configuration that we have found. So the first orbit has 2 electrons, second orbit has 8 electrons, and the third orbit has 2 electrons. See how I have drawn the figure. Now we come to the most important part of today's lesson. Now just see the last orbit. How many electrons are there? 2. So if the last orbit has 2 electrons, then the valency of magnesium is also 2. Now if the orbit has, the last orbit has 1, 2 or 3 electrons, then valency will also be 1, 2 and 3 respectively. In magnesium, there are 2 electrons, so valency will also be 2. You have to see the last orbit to check the valency. As I just told you, if the last orbit has 1, 2 or 3 electrons, then valency will also be 1, 2 or 3 respectively. Now, if the last orbit has 1, 2 or 3 electrons, then it is a metal. Magnesium has 2 electrons in the last orbit, so it is a metal. Like how we calculated for magnesium, we will do similarly for chlorine. Atomic number 17, mass number 35, atomic number, number of protons and number of electrons will be the same, so it is 17. Number of neutrons is mass number minus atomic number, which is equal to 18. Now the electronic configuration. Since there are 17 electrons, the first orbit has maximum 2 electrons, then 8 in the next orbit, and remaining 7 in the last orbit. I've already told you, without filling the first orbit, I cannot jump off to the second orbit, and without filling the second orbit, I cannot jump off to the third orbit. So I fill in the first orbit with 2 electrons, fill in the second orbit with 8 electrons, and the remaining 7 electrons will be in the third orbit. Then we draw the orbit structure diagram based on the electronic configuration. I have already discussed that if the last orbit has 1, 2 or 3 electrons, then the valency will also be 1, 2 or 3 respectively, depending on the number of electrons in the last orbit. But in this case, there are 7 electrons in the last orbit. So what to do? If the last orbit has more than 3 electrons, that means 4, 5, 6, 7 or 8, then we have to minus from 8. Now why 8? Because the maximum number of electrons an orbit can hold is 8. So here in this case the last orbit has 7 electrons, so we minus it from 8. 8 minus 7 equal to 1. So the valency of chlorine is 1. So remember, if the number of electrons is more than 3, 4, 5, 6, 7, 8, then we have to minus from 8 because the maximum number of electrons an orbit can hold is 8. I've already told you if the last orbit has 1, 2 or 3 electrons, then it is a metal. But suppose if the last orbit has 4, 5, 6 or 7, 4, 5, 6 or 7 electrons, then it is a non-metal. So in case of chlorine, there are 7 electrons, so it is a non-metal. Now come to the last example, neon. Like we've already discussed, we will calculate the atomic number, the mass number, the number of protons, the number of electrons, the number of neutrons, and the electronic configuration. Atomic number 10, mass number 20. Since atomic number is 10, number of protons will also be 10. Number of electrons will also be 10. Number of neutrons is mass number minus the atomic number. So 20 minus 10 will give you 10. Electronic configuration. Since there are 10 electrons, the electronic configuration will be 2, 8. First orbit 2 electrons, and then the remaining 8 electrons in the second orbit. Now, based on the electronic configuration, we will draw the orbit structure diagram. 2 electrons in the first orbit and 8 electrons in the second orbit. Now we will calculate the valency. I have already told you if the number of electrons in the last orbit is more than 3, then we have to minus from 8. Here the last orbit has 8 electrons, and we have to minus it from 8. So 8 minus 8 equals to 0. I told you we minus from 8 because the maximum number of electrons an orbit can hold is 8. So here the last orbit has 8 electrons. So 8 minus 8, valency equals to 0. We have already discussed if the last orbit has 1, 2, 3 electrons, it is a metal. If it has 4, 5, 6, 7 electrons, it is a non-metal. Here there are 8 electrons, and therefore it is neither a metal, neither a non-metal, but it is an inert gas. If you see the valency also, we have never studied about valency 0. So only inert gases have valency 0. So what is an inert gas? From the name itself, inert, it does not react with anything or any element. So inert gases are those elements which do not react with any other element. They are also known as rare gases or noble gases. Since the last orbit has 8 electrons, they cannot react with any other elements. So, if the last orbit has 8 electrons, it is an inert gas. So, today we learned how to calculate the valency and to find out whether it is a metal, non-metal, or an inert gas from the electronic configuration. I hope everyone understood it. Thank you. Bye bye.